sine squared x. Now, you know, here we start saying sine squared. Oh my word, what do we do? Well, minus 5 sine of x is equal to 2, right? Now, let's put this into another form that makes it a little bit more familiar. 3 sine squared x minus 5 sine of x minus 2 is equal to 0. Okay, now we start seeing, what if I let sine x, I'm just going to do this on the next page, if I let sine x for this equation, sine squared x, 3 sine squared x minus 5 sine of x minus 2 is equal to 0. If I let sine x equal to p, for example, let sine of x equal p. Now, this here is actually going to be p squared. So I've got 3p squared, right, minus 5p minus 2. Now, people, when you see this, you know, well, Imad, that's just simply a trinomial, very, very easy to solve. So how do we do that? Well, I can put in 3p in there, 3p in there, right, equal to 0. And I look for factors of 6 that are minus to give me 5. So it's going to be 6 and 1. And this is going to be minus 6 plus 1. So the one factor is 3p plus 1. And the other factor is going to be, divide this one by 3. And I'm going to get p minus 2. Okay, that gives me minus 2. That gives me, okay, so that's what it should look like. It's going to be p minus 2 into 3p plus 1 is equal to 0. Okay, so what I was drilling in, guys, here, this is just remnants of algebra. As you can see, this is a trinomial. I've got 3 sine x squared, or sine squared x, minus 5 sine x minus 2. That clearly is telling you that this is a quadratic trinomial. Okay, and with this quadratic trinomial, we can now go back and we can say, once I've factored this, you've seen how I've done it over here. Once I've factored that, this thing actually breaks up into p minus 2 into 3p plus 1, okay, is equal to 0. Now, my apologies, this is when I've let sine x equal to p. Okay, so what does let sine x equals p, what does p actually represent? Well, this is actually going to be, in a bracket, sine x minus 2 and 3 sine x, right, plus 1 equals 0. Now, you know that this represents, using the zero product property, this is the first factor a and this is the factor b. And I'm going to separate each of them now. I'm going to say sine x minus 2 is equal to 0. And on this side, I'm going to say 3 sine of x plus 1 equals 0. Right? This is going to tell me that sine x is equal to 2. And this thing over here is going to tell me that sine x is equal to minus 1 over 3. Okay. Now I want to point out something before we continue further. Second function sine of 2 on the calculator is going to say math error. Okay. And that's because when we look at the sine curve, a sine graph is bounded. If this is my sine graph, it is bounded between the value 1 and the value minus 1. Okay. So therefore, sine x cannot equal to 2, and so we don't need to solve this equation further. However, we need to solve this one further. And that's what I'm going to do on the next page. Sine x equals negative a third. Right. QRS, since it's negative, I'm working in the third quadrant and the fourth quadrant, right? And my reference angle R is going to be x equals sine of a second function of a third. And that's going to give me the following. So I'm going to say second function sine of 1 divided by 3. And this is what I get. 19,47. Right? So 19,5. I'm going to round it off to one decimal place. And that's my reference angle. Now I need to solve this. And I need to solve this using the quadrants that we've indicated. So the third quadrant and the fourth quadrant on this side, right? And how do I do this? Well, I say that my reference angle, my given angle, which in this case is just x, is equal to, in the third quadrant, it's 180 plus the reference angle, 19.5 degrees, plus n times 360, right, such that n is an element of z. 180, this is going to give me 199 0.5 degrees such that n is an element of the integers. On the fourth quadrant, I'm going to say that x, because it's my given angle once again coming from here, is equal to 360 degrees minus 19.5 degrees plus n times 360 degrees. 360 minus 19.5 is 340 degrees, comma 5, plus n times 360, such that n is an element of the integers. Okay, so here's an example where we saw a trinomial and we needed to solve for the general solution, right? Sometimes both of these may be valid. In this case, sine x cannot equal to 2, and therefore this solution here is not valid, right? And as it cannot be. Okay, good.